All right, so you've probably heard this term Industry 4.0 getting tossed around a lot lately. It's supposed to be this huge next level leap in how we make, well, everything. But what does it actually mean? Let's break it down. So, is this whole thing just another bit of corporate jargon that's going to fade away? Or are we genuinely looking at the next chapter in manufacturing? A shift that's as big as, say, the invention of the assembly line? That is the big question we're digging into today. To really wrap our heads around the fourth industrial revolution, it actually helps to take a super quick look back at the first three, because each one was kicked off by a single world-changing technology. It's a pretty clear progression, right? First, you've got steam power, which changed everything. Then came electricity and the assembly line, which gave us mass production. After that, we got computers and the first wave of automation. And that brings us right up to today, to the era of what they call cyber-physical systems, which, in plain English, just means smart machines that can talk to each other and to us in real time. Okay, so with that history lesson out of the way, what exactly is this fourth revolution? It's not just about having faster computers in our factories. Nope, this is about making the entire factory intelligent. So, fun fact, the term Industry 4.0 actually started as a high-tech strategy from the German government back in 2011. You'll also hear it called smart manufacturing, but the core idea is the same. It's about using all these new digital tools to create factories that are connected, smart, and can even operate on their own. I love this way of putting it. It really is that simple. It's about taking all the physical nuts and bolts of a factory and giving them a digital brain. It connects the physical world of machines with the digital world of data. So, how does this all actually work? What's under the hood? Well, it all comes down to a really powerful set of modern technologies that all have to work together perfectly. Let's look at the essential ingredients. Here they are, the big four. You've got the Internet of Things, or IoT, which is basically just putting tiny sensors on everything to collect data. Then you have artificial intelligence and machine learning to sift through all that data and spot patterns a human never could. And of course, you need the cloud and big data analytics to store and process these massive amounts of information. These are really the building blocks of any smart factory. Okay, so here's how they all play together. First, those little IoT sensors are constantly collecting data from the machines. That data gets beamed up to the cloud. From there, powerful AI algorithms get to work, analyzing it all, looking for any little hiccup or opportunity. And finally, based on that analysis, the system either triggers an action automatically, or it sends an alert to a human operator saying, hey, you should probably take a look at this. Let's make this really concrete, because that can sound a little abstract. Imagine a critical machine on an assembly line. An IoT sensor picks up a tiny microscopic vibration that's just a little bit off. The AI analyzes that vibration pattern and predicts that a specific bearing is going to fail sometime in the next 3 days. So what happens? The system automatically orders the replacement part and schedules a maintenance slot during the next planned shutdown. The result? Zero surprise downtime. That right there is predictive maintenance, and it's a total game changer. Okay, the tech is seriously cool, but let's talk about the bottom line. What's the actual business impact? What's the payoff for a company that makes this massive investment? Well, the numbers are pretty mind-blowing. Get this, according to research from IBM, smart manufacturing can slash production defects by up to 50%. 50. I mean, that's a huge deal. It means way higher quality products, less waste, and a lot more happy customers. And it doesn't stop there. Those same systems can boost manufacturing yields by as much as 20%, so you're getting more finished products from the exact same amount of raw material. That is a massive win for efficiency and, of course, for the bottom line. But here's the thing. This isn't just about making the same stuff better or faster. It's a fundamental shift in how we think about production. Industry 3.0 was all about mass production, making millions of identical things. Industry 4.0 is all about mass customization. It's the ability to make a unique item for every single customer just as efficiently as you could make a million identical ones. Think about a factory that can build a car to your exact personal specs without slowing down the line. That's the dream of a lot size of one. Now, as incredible as all this sounds, the path to a fully smart factory isn't exactly a walk in the park. It's really important to be realistic about the challenges and what the future looks like. You've basically got 4 big roadblocks. First, the upfront costs can be staggering. Second, connecting everything to the internet opens up a whole new world of cybersecurity risks. Third, getting all these different systems from different companies to actually talk to each other can be a total nightmare. And finally, just the sheer complexity of setting this all up and keeping it running requires a whole new set of skills. So, yeah, because of those challenges, Industry 4.0 often feels like a game that only the big corporations can afford to play. For now. But almost every expert is optimistic. As these technologies get more mature, they're going to get cheaper, easier to use, and more standardized. And that means they'll be within reach for smaller companies too. And that leaves us with one last really big question to chew on. This revolution, it isn't just about efficiency or profit margins. It's about building factories that are truly intelligent, factories that can learn, predict, and act on their own. So, when our factories can literally think for themselves, what does that mean for the future of work? And what does that mean for us?